Let us see syndrome calculator circuit, or we can say syndrome, or we can say cyclic decoder. So this circuit is for 7, 4 cyclic code with a gx equal to x cube plus x square plus 1. Now, how to form this circuit? So for that you have to see the power of this gx, highest power of this gx, which is also called degree. So that is equal to 3. So there are 3 flip-flops. So flip-flop 0, flip-flop 1, flip-flop 2. So how many flip-flops are there depends on highest power of gx, that is 3. After that this structure is this line is always there, only you have to see which adders are added. This adder is always there. So this line corresponds to coefficient of x cube, that is equal to 1. So this line appears because coefficient of x square is 1. This line and that adder is not there because x is not there. After that 1 is there, this one, so this line appears. So this is about how many vertical lines appear and how many flip-flops are there. Flip-flops depends on degree of gx, that is highest power of gx. Then vertical lines depends on which coefficients are present. This line is for coefficient of x cube, this line is for coefficient of x square, this line is for coefficient of x, and this line is for coefficient of x raised to 0, that is 1. Okay, so after that here the input is from this side, that is received code word, and there are two switches. This is switch 1 and switch 2. If you don't draw switch 1, it will be okay, there is no problem. Switch 2 will be at position 1 and position 2. So so there are two positions for switch 2. So initially input y is this one, 7-bit is your input because code is of 7 bits. So received code word is of 7 bits. So until 7 bits are entered into the, that means all the 7 bits enters into the circuit, at that time this switch 2 is at bit position 1 until all 7 bits comes into the circuit. After that when the received code word totally enters into the circuit, after that the switch 1 is open and this switch comes at the position 2 to take the syndrome out. Initially switch is at this switch is when received code word enters into the circuit, this switch is open, this switch is closed, and this switch is at the position 1. Once the received code word totally enters into the circuit, then this switch is open and this switch comes at the position, this position, that is position 2, which I have not written here, but it is position 2, so that syndromes will be taken out. Now after that how to we have to form these equations. So these equations are writing about the inputs of flip-flops. So flip-flop 0 input is equal to y plus flip-flop 2 output. After that flip-flop 1 input is equal to flip-flop 0 output. Flip-flop 2 input is equal to flip-flop 2 output plus flip-flop 1 output. So these equations you have to write. So this is mod 2 operation. So plus means mod 2. After that we have to form this table. For that you have to consider input as the row you are calculating and or present row, and output here, wherever output is written, you have to consider it as a previous row or previous row. Okay, so initially when y is not there, flip-flop 0, flip-flop 1, flip-flop 2 outputs will be 0, 0, 0. After that you have to write y. So what is y? Y is equal to 1 0 0 1 0 0 1. So same is written here, 1 0 0 1 0 0 1. So Here I have drawn some arrows to show these operations, which you don't draw in your exam. This I have drawn only to show you how these operations are occurring here. So first operation is flip-flop 0 input. That means you have to compute present row for this flip-flop, or you have to compute this row. Input means present row. So for that, the flip-flop 0 input is equal to y plus flip-flop 2 output. So y is 1, flip-flop 2 output is 0. So 1 plus 0 is 1. Flip-flop 1 input is equal to flip-flop 0 output. So previous row. Then flip-flop 2 input, that means you have to compute this one. Flip-flop 2 input, input means present row, is equal to flip-flop 2 output, this one previous, and flip-flop 1 output previous, that means 0. 0 plus 0 is 0. So once you understood these operations, there is no need to draw these arrows or these lines. So we have drawn this for bit 1 bit, that is first bit of y, that is MSB of y, which is equal to 1. Now other bits are 0 0 1 0 0 1. So let us do these operations again. So 0 plus 0 previous, 0 plus 0 is 0, this one will appear here, and 0 plus 0 is 0. These operations we have drawn here. Okay, then this row, 0 plus 0 0, this 0 will appear here. Then 1 plus 0 1. Then after that 1 plus 1 0, this 0 comes here, 0 plus 1 is 1. Then 1 plus 0 is 1, this 0 appears here, 0 plus 1 is 1. 1 plus 0 is 1, this 1 appears here, 0 plus 1 is 1. Then 1 plus 1 is 0, this one appears here, then 1 plus 1 is 0. So this is your final syndrome. So how to write the syndrome? You have to go from S2 to S0. Why? Because S2 comes first when you take the syndromes. S2 comes first, then S1, S0. So output, syndrome output is 0 1 0. So this is it for the decoder diagram and this table and syndrome calculation. In exam, if you have time and you have solved this problem, you can cross verify your answer with this method. For that, you have to use the division method. In that, you divide yx by gx and compute the syndrome. So yx, you have to form yx from this y. So you know how to form the bits, how to form the polynomial if you have given the bits. So there are 7 bits. So first power will be x cube. So x raised to 6. So first power will be x raised to 6. Then x5 is not there, x4 is not there. Then x cube. Then x square is not there, x is not there. Then 1. So x raised to 6 plus x cube plus 1. You know how to form the polynomial from the bits, which we have taught in one of the video. Okay, so after that you have to divide this yx with x cube plus x square plus 1. So first division will be x raised to 6 by x cube is x cube. X cube is first quotient, so first part of the quotient. So x cube you have to multiply with all this. So x cube into x cube is x raised to 6. Then x cube into x square is x raised to 5. X cube into 1 is x cube. Similar will be x raised to 6 gets cancelled out, and x3 gets cancelled out because 1 plus 1 is equal to 0. The remaining is x raised to 5 plus 1. Okay, so x raised to 5 by x cube, quotient will be x square. Then x square you have to multiply with all these terms. Okay, so x square into x cube is x raised to 5, x square into x square is x raised to 4, x square into 1 is x square. After that x5 gets cancelled out, remaining is x4 x square plus 1. Now here x4 divided by x cube is x, so the quotient will be x. So x, you have to multiply this x with all these terms. So x into x raised to 3 is x raised to 4, x into x square is x cube, x into 1 is x. Similar, x4 gets cancelled out, remaining is x cube plus x square plus x plus 1. You have to write down in the descending order always, otherwise you will not get the quotient correctly. Then x cube is x cube divided by x cube is 1. So the quotient will be 1. So multiply 1 with all these terms, that will be x cube plus x square plus 1. So similar, x cube gets cancelled out, x square gets cancelled out, 1 gets cancelled out, remaining is x. So this is your syndrome. Now how to form it in the bits, how to represent in the form of bits is, you should know how many bits are there in the syndrome. For that you have to again see the degree of gx, that is equal to 3. Degree of gx is 3, that means syndrome has 3 bits. If syndrome has 3 bits, then its highest power will be 2. Its highest power of the polynomial will be 2. So x square is not there, so write down 0. Then x is there, so write down 1. Then 1 or 0 is not, 1 is not there, so write down 0. So Sx in the polynomial form will be 0x square plus x plus 0x raised to 0. So that is equal to 0, 1, 0. 0, 1, 0. So same you have got here. But only attempt it if you have time, because it also takes time. But you have time, then you can cross verify your answer.